Welcome to another session of JS Networks. In today's class, we are going to learn what is Floyd Warshalls algorithm or Warshalls algorithm. And this is all pair shortest path algorithm. Warshalls algorithm is a dynamic programming algorithm used to find the shortest path between all pairs of vertices in a weighted graph. That is, it is used to find the shortest path between each pairs of vertices, all the pairs of vertices, and the graph is weighted graph. That is, the edge will be having values. It calculates the shortest path by considering the weight of each edge and the distance from the starting vertex to each vertex. So that is what Warshalls algorithm says. So let me explain Warshalls algorithm with an example. Here is an example given to you. This is having 4 vertices 1, 2, 3 and 4. Labels given to the vertex are 1, 2, 3 and 4. Okay. And this is a directed graph. And each edge is having weight. That is, it is a directed weighted graph or weighted directed graph. Okay. So now we are going to apply Warshalls algorithm to this graph to find all pairs shortest path. Okay. For that, we are creating distance matrix. And the matrix is having the size, it is n cross n matrix, that is n rows and n columns. N is the number of vertices. Here 4 vertices are there, right? 4 vertices. So 1, 2, 3, 4. Name of the rows and columns 1, 2, 3 and 4. Okay. Now this is the distance matrix D0. And D0 we are getting directly from the graph. It is the direct output of the graph. So let us see how we are preparing D0. Okay. So just form the matrix with rows and columns. Then we are going to give the entries to this. So first you have to do, for the diagonal values, give 0. That is 1 to 1 0, 2 to 2 is 0, 3 to 3 is 0 and 4 to 4 is 0. Or else by calculating also you will get the same value. Okay, 0, 0 like this. Now, or else you see 1 to 1, no self loop is there. 1 to 1 means self loop, right? You know this is a self loop, this is self loop. So here we are not having self loop, so we are marking as 0. Or while calculating also you will get 0 only. So for the diagonal values, write 0, enter the value 0. Now first row and second column, that is 1 to 2. 1 to 2. Okay. So we have to check whether a directed edge is there or not. 1 to 2. See, for 1 to 2, see, this is arrow is to this side, right? So that is from 1 to 2. And the edge value is 8. So here you have to enter 8. Now next is 1 to 3. So 1 to 3. We are not having. We are having 3 to 1. See this. Arrow is from 3 pointing towards 1. Okay. So we are not having 1 to 3. There is no relation, no edges there. Okay. So in that case, we are entering here infinity. Next is 1 to 4. 1 to 4. An edge is there and the value is 1. So 1. Okay. First row is over. Now come to the second vertex. That is 2 to 1. 2 to 1. We are not having relation from 2 towards 1. So we are entering here infinity. Okay. Then 2 to 3. 2 to 3. See, this is 2 to 3 and the value is 1. And 2 to 4. 2 to 4 we are not having. We are having 4 to 2. Okay. So 2 to 4 it is no relation. So we are writing infinity. And then that row is finished. Now we are coming to the third point. 3 to 1. Vertex 3 to 1. Here it is 4. Okay. And 3 to 2. We are not having 3 to 2. So it is infinity. And 3 to 4. That is also infinity. Okay. And then 4 to 1. 4 to 1 we don't have. So infinity. 4 to 2. 4 to 2 we are having 2. See 2. And 4 to 3 is 9. See, we got the distance matrix D0 and the values are 0, 8, infinity 1, infinity 0, 1, infinity, 4, infinity 0, infinity, infinity 2, 9, 0. Hope this is clear. That is, from the graph you have created the first distance matrix. Okay. So this is the first distance matrix. Now we are going to create the second one, that is D1. We are having 4 vertices, 1, 2, 3 and 4. So we have to create D1, D2, D3 and D4. First you are creating D0 directly from the graph. From D0 we are creating D1. From D1 you have to create D2. From D2 we are getting D3 and from D3 we are getting D4. Okay, 4 vertices. So D1, D2, D3 and D4. Okay, D0 we are getting directly from the graph. Now this is the D0 which we have calculated. Now we are coming to D1. Okay, D1 means we are going via 1. That is, we are traveling via node 1 or vertex 1. That is D1. Okay, traveling via 1. That node we know, which is having the value 1. We are traveling through, we are passing through, or we are passing via node 1. Okay. Now here also diagonal element, make the entry 0. Okay. Now this is via 1. Okay. So from D0, this row, that is the first row and the first column, we are copying it directly to D1 since it is D1. Okay, so since it is D1 here, that is why the first column and the first row we are writing same as that of D0, that is 0, 8, infinity 1, and here 0 infinity 4 infinity, right? 0 infinity 4 infinity. Okay, since it is distance matrix D1, so first row and first column we are entering the same as D0. Just copy it. Now we are solving it. Now we are having 2 3. Okay, this point we are doing D1, that is via 1. So, and we are going to calculate this value 2 3. Okay, so in Warshalls algorithm, using Warshalls algorithm, we are solving it by, that is we are going to find 2 to 3 and we are doing it through 1 or via 1. Okay, so 2 to 3, this point, that point means 2 to 1 plus 1 to 3. Okay, this is via 1, that is 2 to 3 is this one which we are going to find, and 2 to 3 means 2 to 1 and 1 to 3. Okay, so 2 to 1 plus 1 to 3. Now we have to take the value of second row, intersection point value of second row and third column. See this one, and we know, as I told before, we are getting the values of D1 from D0. Okay, so 2 to 3, second row and third column, the value is 1. So 1. Okay, and 2 to 1, 2 to 1 is infinity. 1 to 3, 1 to 3 is infinity. So you are going to add this. Now for getting the value, you have to find the minimum of these values. Okay, 2 to 3 you will get a value 1, and 2 to 1 plus 1 to 3, that is infinity plus infinity, that is also infinity, right? So this is infinity plus infinity means 2 infinity. Okay. So this is naturally bigger than 1. So 1 is minimum value, and we are having the entry here 1. Okay, let us take the minimum value of 2 to 3 and 2 to 1 plus 1 to 3. So the least value is 1, minimum value is 1. So this one we are entering in this point. Now infinity to 1, 2 to 4. Next is 2 to 4, that is this point. Okay, so 2 to 4 is, we are going 2 to 4 and we are doing it via 1. So 2 to 1 plus 2 to 1 plus 1 to 4. Okay, and 2 to 4, the value we have to get from D0. 2 to 4 is infinity. Now 2 to 1, 2 to 1 is also infinity, and 1 to 4, that is 1. Okay, so compare, take the minimum, infinity and infinity plus 1. Now from this itself we can understand infinity is smaller than infinity plus 1. Okay, so take the minimum value and make it as entry. Okay, now I'll show you one more, this one also, 3 to 2, 3 to 2, intersection is this one, right? So 3 to 2 we are writing as 3 to 2 means we are doing it via 1. So 3 to 1 plus 1 to 2. Okay. So 3 to 2, the value is 3 to 2 is infinity, and 3 to 1 is 4. So 4 plus 1 to 2. 1 to 2 is 8. So this is adding 12 you get. So take the minimum value of infinity and 12. We know 12 is lesser. Okay. So take 12 and enter it. I'll show you this also. That is 4 to 4. Not 4 to 4, sorry, 3 to 4. Okay. 3 to 4. So 3 to 4 means we are writing it, we are doing it via 1. So 3 to 1 plus 1 to 4. Okay. 3 to 4 is infinity. 3 to 1 is 4 and 1 to 4 is 1. So this is 5. Compare infinity and 5. 5 is less. So we are making the entry 5. That is D0, distance matrix D0 we got from the graph, and D1 we are getting from D0 and D2 from D1, like that. Take the minimum value. Okay. Now this is D1 which we got. Now from D1 we are going to get the value of D2. Same way, diagonal values make 0. Okay, here D2, right? So since it is D2, second column and second row, these values we are taking from D1. This is D2, so we are taking all from D1. Okay, so second row and second column, this is 8, 8, 0, 12 and 2, 12, 2, and second row is infinity, 0, 1 and infinity. Okay, now we are going to form the entries. 1 to 1 we have 0, 1 to 2 we have 8. Now 1 to 3. Okay, so 1 to 3 we are doing it. Since this is D3, it is going via 2. Okay, so 1 to 2 plus 2 to 3. We are splitting this. Okay, that is 1 to 2 plus 2 to 3. Now take the values from D1. 1 to, this is 1 and 1 to 3, it is infinity. Now 1 to 2, it is 8 plus 2 to 3. 2 to 3 is 1 and this is 9. Okay, we know 9 is lesser than infinity. So make the entry 9. I'll show you this one, that is 3 to 1. Okay, 3 to 1 means, since we are doing it via 2. Okay, so 3 to 1 is 3 to 2 plus 2 to 1. So 3 to 1, 3 to 1, it is 4, and 3 to 2 is 12, and 2 to 1 is infinity. So naturally this is bigger than 4. Seeing this 12 itself, we can stop because it is bigger than 4. Anyway, after adding, it will become more bigger. Okay, so make the entry 4. So likewise, we have to complete D2. See, you got the D2 like this: 0, 8, 9, 1, infinity 0, 1, infinity 4, 12, 0, 5, infinity 2, 3, 0. Now we are going to calculate D3, that is via 3. Okay, diagonal entries make 0, and now here via 3. So third row and third column. Third row and third column, write the same as D2. So third column is 9, 1, 0, 3, and third row is 4, 12, 0, 5. Now make the other entries same way. Here 1 to 2. Okay, this one 1 to 2. We are going it through 3. Okay, so 1 to 2 is 1 to 3 plus 3 to 2. So 1 to 2, it is 8, and 1 to 3 is 9 plus 3 to 2 is 12. So lesser one is 8. So make the entry 8 here. Okay, now I will generate this 4 to 1. So 4 to 1 is, we are doing it via 3. So 4 to 1 is 4 to 3 plus 3 to 1. So 4 to 1 is infinity, 4 to 3 is 3 plus 3 to 1 is 4. So it is 7. Okay, 7 is lesser than infinity. So make the entry as 7. Okay, now this is the D3 distance matrix. Now we have to calculate D4. Again, diagonal elements 0, and since this is D4, fourth column and fourth row, write the same as fourth column and fourth row of D3 matrix. Okay, so fourth column is 1, 6, 5, 0. So this 1, 6, 5, 0, and this one 7, 2, 3, 0. Okay, now we are going to calculate 1 to 2, this value. So since this is being done via 4, so 1 to 2 means 1 to 4, and that is plus 4 to 2. 1 to 2, 1 to 2 is 8, and 1 to 4 is 1 plus 4 to 2, it is 3. 4 to 2, not 3, it is 2. Okay, and so the sum is 3. So compare 8 and 3, take the minimum value, and we are entering 3 here. And come to this one, 3 to 1. Okay, so 3 to 1 is 3 to 4 plus 4 to 1. See this and this. This is the starting value and this is the ending value. Okay. In between you are writing the distance matrix number. So that is D4, D4, D2, D3 like that. Okay. So 3 to 1 we are getting 4 and 3 to 4 is 5 plus 4 to 1 is 7. So this is less. Okay. So we are entering here 4. Hope this much is okay. That is D0 we are getting from the graph directly, and then from D0 we are preparing D1, from D1 D2, from D2 D3, from D3 D4. Since here we are having 4 labels, 4 vertices, 1, 2, 3, 4, so we need up to D4. Okay. Now this is the output which you get, and this is distance matrix 4. See this, no infinity here is here in this matrix, right? That means it has been reduced. Okay, the values have been reduced. Just compare the matrices, the values have been reduced. So this is the shortest path, all pairs. Okay, from 2 to 1. 2 to 1 is a pair, right? The shortest path is 5, shortest point, edge value, that is 5. 4 to 2, it is 2. See this. So this is the final output. This is the shortest path. Okay. This is the algorithm. N is the number of vertices, A is the matrix of dimension n cross n. So these are the terms which we have used in this algorithm. N is the number of vertices, A is the name of the matrix. See, for k is equal to 1 to n, for I is equal to 1 to n, and j is equal to 1 to n. Akij, and k is the, that is, there we have noticed from D1 you are creating D2, right? From D2 you are creating D3, like that. Okay, suppose now you are going to create D2, for example. So k is 2. Okay, so that is A, K, Ij. Ij is a row and column. Now 2 is K. Okay, D2. So D2 we are creating from, we are preparing D2 from D1. See, here k is 2 and here k is 1. That is k minus 1. Right? Akij. That is D2. Second one is equal to minimum of. We are taking the minimum of A k minus 1 of ij. That value. This k minus 1. That is for preparing. Suppose you are first row and third column you are going to get prepare, you wish to get the value, that is 1 to 3 of D2. So for that what you will do, you will take the minimum of 1 to 3, and since it is via 2, 1 to 2 and 2 to 3, right? So from D1 you are getting the value of D2, that is k minus 1. That is why ak minus 1 ij, and then ak minus 1 ik plus ak minus 1 kj. That is what? See, if you are going to get the value of 1, 3, if you wish to get the value of 1, 3, what you will do? You will take the minimum of 1 to 3 value, and since we are doing it via 2, so 1 to 2 plus 2 to 3. Okay, that is what? K minus 1 ik, k minus 1 kj. So this is the algorithm for Floyd Warshalls shortest path. Just you have to keep in mind this line, the statement. Okay, else is very easy. For k is equal to 1 to n, for I is equal to 1 to n, j is equal to 1 to n. This is the formula, and then print the, display the matrix. That's all. It's very simple. So we have covered Warshall's shortest path algorithm in graph. This is very, very important in data structure. Hope it is clear for you. Thank you.